Hello viewers, this is Dr. Dheeraj Malhotra, and today we are going to discuss implementation of dynamic queue. Earlier we had discussed about static queue implementation. So here we go. Okay, so implementation of queue using arrays has been already discussed, that you can watch in my previously uploaded videos. So today we are going to discuss about dynamic queues, that means queues implemented via linked list. So as we all know that queue is a dynamic data structure, linked list is a dynamic data structure, and if we implement queue using linked list, then we can call it dynamic queue. Okay. Moreover, we know unlike stack, here we have two pointers, that is front and rear. Okay. Front is a position from where deletion take place, and rear is a position from where insertion take place. Okay. So if we talk about insertion in linked queue, so that is similar to insertion in singly linked list, and which case I hope you all have studied various possible types of insertion in linked list, that is insertion in beginning, insertion at end, and insertion in between. So I hope you can easily guess that while doing implementation of queue, we need to perform insertion at end. Okay, so if you know the literal meaning of queue, then also you can easily guess. So for example, if there is some queue on a box office, then any new entrant is required that he or she should stand in the last, that means insertion at end. So let us discuss insertion in queue by the help of diagram first. Okay, so suppose we have a queue with 5 nodes, that is this one. Okay, from 4 to 65, 4, 23, 6, 13, 65. These are the information within the nodes of our queue, and we wish to insert one new node having information 40. Okay, so obviously, as I already told you, that insertion in a queue is similar to insertion in linked list at the end. Okay, so while doing insertion at the end, what all we need to do, we need to allocate the memory for new node, we need to put the information in it, and we need to put null in the next part of it, because this is going to be the last node, and then we need to put the address of this new node in the next part of the second last node. For example, as we can see that 65 is going to be the second last node as soon as we insert 40. Okay, so that is possible only if we overwrite this null with the address of this new node. Okay, so these three things we need to do, information and null we have to insert within new node. Okay, and then we need to put the address of new node within the second last node. We need to overwrite this null. Okay, so we will soon discuss the implementation part through code. Okay, so if we talk about deletion, so deletion in queue is similar to deletion in deletion in beginning of a linked list. Okay, so for example, if we have this queue, so while doing deletion operation, we need to always remove the first node. We cannot give option to the user that you can delete from random location that is in between or at end or in beginning, whatever. We need to just give only one option in menu, that is deletion, and because we know the deletion always take place in front of the queue. Okay, so as soon as we delete the first element, then we need to update the front pointer to the second node, because second node is going to be the first node of new list. Okay, so let us see the implementation part. So if we are going to implement queue using singly linked list, then self-referential structure is simple. It's consisting of only two fields, that is information part and next pointer of the struct node type. Okay, front and rear we have declared here global. Okay, otherwise you can always pass in various functions and they are set to be null. It should be noted that pointer should not be kept empty, and you cannot initialize pointers with 0. So by default we always keep null, and these are the functions we are going to define: insertion, deletion, display. Okay, insertion will take value from the user, and this is our infinite loop, because we want that program should run until or unless user prompt to exit. Okay, so we will accept the choice from the user and accordingly we will call the function. Fine. So case first is for insertion, case 2 is for deletion, case 3 is for display, case 4 is for exit, and otherwise we will print wrong choice. So if you see the insertion part, we are passing the value from user here, okay, and we will then allocate memory using malloc, and whatever is address returned by malloc after typecasting, we will store it in pointer called new node. Then we will put this value from user into the info part of new node, and also because we know that in queue insertion will always take place at end and the last node always consists of null, so that's why we are putting null in the next part of the new node. Okay, so there is possibility that we are doing insertion for the first time, means it is going to be the first node of the queue, so that's why we are checking whether front is already null. If so, then front and rear both will point to the new node. That means this is our first node as well as last node, because front always points to the first node and rear always points to the last node. But what if we have only one node in the list, then both will point to the same node. Okay, and this is the case of only node, and otherwise, for example, already few nodes are existing in the queue and we are creating new node, then what we are going to do with the help of rear pointer, because rear always point. See, this is the major difference between stack and queue. In stack we are not maintaining the last pointer. In fact, we need not, because whatever we are going to do in the stack, there is top. Okay, and we always do insertion as well as deletion from the top, but here we are maintaining two pointers because for insertion we need to insert at last, so that's why we have rear pointer there. So by the help of rear, which is already pointing to the last node, we will put the address of new node in the next part of existing node by using this, and then we will update the rear pointer, because after inserting new node, then new node will become the last node and rear always point to the last node. Okay, then for user satisfaction you can print acknowledgement message like success. Okay, now this is the deletion part. Here we are having temp pointer, so deletion always takes place from front. So first we need to check whether there is underflow error or not. If so, then if, for example, if front is null, that means queue is empty, so we cannot delete. Then we can print underflow error if you want. Otherwise, by the help of temp pointer, we will first point temp pointer where front is there. For example, we know that front always points to the first node, so temp also starts pointing to the first node, and then we can safely move our front pointer to the second node. Okay, because normally we don't move front pointer, because otherwise we will lose the track of our list, our queue. So after pointing temporary pointer to the first node, then we will move our front pointer to the second node, and then we will print that whatever is deleted value, and then we will free is the library function available in alloc.h, and we can free the memory through it. Display is quite simple. For example, if list is empty, that can be easily checked through this statement if front is null. Otherwise, by the help of temporary pointer, by pointing it to front and moving it till rear or moving it till we come across null in the next part, we will print the information, and to move further we always use this statement. So this is how output would be shown as a menu. Okay, and then you can input choice, and accordingly you can do insertion, deletion, etc. So that's it for today. Thanks for watching.